Okay, let's do this. So, technetium. Oh, shit, yeah. I know I have a good way to do this. Okay, so this is the periodic table, right? Except for, we're going to ignore everything past Americium for now. So, curium, berkelium, californium have half-lives long enough for you to collect, but I don't have them. Anything past that, its half-life is so short that you can't really have it, honestly. You couldn't even... I don't think anybody could own it. Even if they're rich. Like Oganesson, half-life of 0.7 milliseconds. Yeah, you're not going to have that. I mean, that's just too short of a time to exist. But yeah, Americium, we'll start... So everything from 1 to Americium, so 1 to 95 protons in the nucleus. So I have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, gallium, germanium, arsenic, selenium, bromine, krypton, rubidium, strontium, yttrium, zirconium, niobium, molybdenum. Here's the first one I don't have, technetium. I don't have that shit. Not yet. But I plan on buying it. They do synthesize it. As you can see, it's radioactive. Just right in the plop middle of the stable elements. Very unique. I have ruthenium, rhodium, palladium, silver, cadmium, indium, tin, antimatter, tellurium, iodine, xenon, cesium, barium, lanthanum, cerium, praseodymium, neodymium, promethium I just bought, so even though it's radioactive, I have it. Samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium, hafnium, tantalum, tungsten, rhenium, osmium, iridium, platinum, gold, mercury, thallium, lead, bismuth, polonium I have in decay chains. I do not have astatine. I need that in decay chains. What I mean is that bigger radioactive elements decay into astatine. That's the only way you can get it, is by its creation from a bigger atom decaying into it. I have radon from decay chains. I do not have francium from decay chains yet. So you can see I have a few radioactive elements from decay chains. You'll see why in a second. Radium I have in decay chains. I do have actinium in decay chains. The reason... Okay, so I do have thorium, like literally visible thorium. Its half-life is 14 billion years, so half of it will disappear in 14 billion years. Not disappear, but turn into radium in 14 billion years, I think. I think it's radium. So this is a big part of all these other radioactive elements that isn't... This is the start of the decay chain. I have prosactinium from decay chains. I have uranium. Its half-life is 4.5 billion years. So I just have it. I mean, that's enough time for us to collect some without it decaying. And that creates some decay chains as well. I have neptunium from the decay chain of Americium. I do not have plutonium yet. And then I have Americium. We synthesize that from, I think, uranium or something. I think we shoot some neutrons at uranium or some sort of process. Or at plutonium. I'm not sure. I'm not sure the process of how plutonium or Americium is synthesized. But I know that I just bought some Americium. It's pretty common, actually. It's in smoke detectors. The fact that we can just synthesize this stuff is just crazy to me. So that would be the biggest one that I have. As you can see, curium's next, and then all these that are really big, from element 95 to element 118. You can see all these are very, very rare. These three we could make, right? And they last quite a while. At least some of the isotopes. And then Einsteinium and everything after is just so short-lived. Like, I think there's some that have hour half-lives or something around here, or days or something. I forgot. But everything past that is like just so unstable. All right, well, I guess thanks for watching.